Hey Islanders, welcome back to another episode, and today I'm really excited to show all of you the second part of why linked lists are so amazing. So for those of you that do not know who I am, I'm William McKeon. I'm an electrical engineer turned computer scientist, but everything you all see on this channel I taught myself using YouTube. So with all that being said, why don't you hit that subscription button as well as that bell icon if you have not yet done so, as well as sit back, relax with your favorite snack, and let's get started. Hey honors, I'm so excited to be showing all of you today's video, but real quick, let me know down in the comment section down below based off of what you know about linked lists, as well as let me know at the end of today's video on what type of projects do you think you could be using linked lists for. I really can't wait to hear all of your responses, as well as today's video in no shape or form is really a tutorial fully on all the materials that we're talking about. I mean, really, there's so much that we're going to be going over. There's no way I could possibly be able to get it done all in one video. As well as, I know stock analysis tool is in today's title, but today's video, as well as none of the videos on my channel, is going to have anything to do with financial aid. And with all that being said, why don't we actually just dive into probably one of the easiest methods I've ever created in my life, and that is over here on line 39, def size. Technically, you could just have the user say just be going into their instance of this class and pulling out what the size is for this. But for some of those people that really like having a method to return specific values, this is the simplest way to actually return the size. And knowing the size of your linked list is actually very important because it allows you to manipulate your linked list in various different ways. All right. So, and then really the next method right after the size method is also a very simple method, and that's the contains method. The whole purpose of the contains method is really just to traverse through your linked list to find out if there is any instance of the specific symbol or whatever you decide to have your contains look for inside of your linked list. All right. Also, if you really want to go over today's code, there is a link to a Google Colabs down the description bar down below. It'll have every note I have in regards to this project all down in that Google Colabs. So go ahead and check that out. And we're actually going to be moving on to a method that's very similar to a method we were talking about in the last video, and that is this method over here on line 49, which is the insert method. Really, there's two huge main differences between the dynamic method that we're talking about in the last video and the insert method that we're talking about right now. But there's also two real main similarities between them, and we'll get to those in a second. But one of the main differences that this method has that the dynamic method doesn't have is we actually have an input argument of index. And really what we're using this index to do is to be able to tell where exactly in our linked list we want to be adding this new data. For instance, where we have similarities between the dynamic and the insert is over here on line 50, where we're saying if the index is equal to 0, meaning we actually want to be adding our new node to the very beginning of our linked list, hence the index equal to 0. Therefore, we're going to be calling the self.pushback, and we're going to be placing all the input arguments that I didn't just specify besides index into the input arguments for self.pushback. Therefore, to allow us to create a brand new node that's going to be added to the very front of our linked list. And then once we've actually completed that linked list, or once we've completed that call, we're going to be returning out of this method into the main program, because there's really no point to be continuing on with the rest of this method, just really because it's going to be going on. It's going to probably cause some errors as well. And then once we say for some reason we have entered an index value that's greater than or equal to the self.size, therefore we want to be actually adding this new node to the very end of our linked list. Therefore, we're going to be saying self.pushback, and we're going to be doing the same input arguments that we were just specifying for self.pushfront. Now, one of the main differences between this method and the dynamic method is, say for instance, if we have to add some sort of value inside the middle of this linked list that's neither at 0 nor is it at the very end of the linked list. Therefore, we're going to be creating a brand new linked list called temp, and we're going to be setting that equal to the memory address of self.head. And then we're also going to be doing is we want to keep track of the current index. Remember, linked list is a data structure that we don't exactly have indexes built into the data structure. It's something we have to manually be keeping track of. So that's why we have current index equal to 0. And then really what this current index is going to allow us to do is be able to create a while loop saying while the current index is not equal to index minus 1, traverse through the temp node, all right, as well as plus equals the current index. Once we break out of that while loop, we're going to actually be creating a brand new node called new node, and we're actually going to be calling the node class, and we're going to be passing in values for the next value, which is going to be the temp.next. So therefore we can actually, this is where we're actually going to be splitting apart this linked list to be adding in this new value. Once we specify that new node and we've created that new node, the programs are going to be going on to line 64, where it's going to be saying temp.next equals new node. And really once we've done that, we're also able to now say self.size plus equals 1 because we've added to our linked list officially. All right, really this behemoth looks a lot more complicated and what's the word, scary once you first start looking at it. But really once you start to understand, just like many other softwares, once you really start looking at it and understanding, it's not as intimidating as it once was. All right, and really just as important as inserting data, you really have to be able to deleting the data, which is exactly what we're doing over here on line 67. Ironically, this method is going to be called delete, and we're actually going to be passing an input argument of symbol. When you make your own linked list, you can have symbol be whatever you want. In my circumstance, symbol is going to be a string value. All right. As well as I really just want to point out, in my opinion, delete is probably one of the most complicated methods when it comes to linked lists. For a few reasons, I will point them out as we continue on explaining this method, but I really just want to point that out. This method is a very, very complex method. And really, once we've created this method and we've defined this method, we're going to be creating two new nodes. One's going to be called current, and we're going to set that equal to the memory address of self.head. Then we're also going to be creating a previous node, and we're going to set that equal to none. Reason being is because we don't want previous equaling to anything, because previous is actually going to be trailing behind current. All right. Once we've actually created those two nodes, we can actually go into the first if statement over here on line 71. And really this if statement is checking to see if the symbol that we're looking for is equal to the very first symbol of our linked list. We're saying if current.symbol equals the symbol that we passed in, we're going to say previous equals current, and then we're going to say self.head equals the next value of current, or the next node of current. Once we've done all that, we're going to say delete previous. But we just said on line 72 that previous is equal to current. Why are we now deleting it? Well, the reason why I believe delete is one of the most complicated methods is because this is where you can have memory leaks within your linked list, which will cause a whole boatload of headaches later on in your software if you're not aware of them. And in order to get around those memory leaks, we first have to set previous equal to some value besides none. Once we've done that, we can actually then, like we did on 74, delete that node. All right, and then once we've successfully deleted a value from, a node from our linked list, we're going to say self.size minus equals 1, therefore meaning our size actually decrease. And then we're going to actually continue on to this else. This else is representing if the symbol that we're looking for is not equal to the very first value of our the very first node of our linked list. All right. And then if it is, and we do get onto this else, we actually have to traverse through this linked list by stating while current.symbol is not equal to the symbol, as well as while the current is not none, we're going to be saying previous equals current. Reason being is because previous is trailing behind current. Remember that. Once we have said what previous is going to be equal to, then we can have current continue on to the next value. And then once we break out this while loop, we're going to check if current is actually equal to none. If it is not equal to none, we're going to allow, the software is going to be like, okay, this if statement is true. Over here on line 89. Once we go into that first if statement, we're actually going to be going into another if statement to check if the current value is equal to the tail, therefore meaning the value that we actually want to delete is at the very end of our linked list, which actually makes life a lot easier because we just say self.tail equals the previous. If we are actually going in through this linked list and that if statement on line 81 is false and we go on to the rest of the software, we're just going to say previous.next equals current next, and then we're going to delete the current. All right. And then once we've done all that, we've successfully deleted a value from our linked list. All right, thus allowing us to have the ability to actually be coming up with test cases like we're doing over here on line 87 all the way to the very end of line 99. Really though, I just want to point out we can actually just create a print statement right here where we say print real quick side note, this is not sponsored, but tab 9, if you're a Mac M1 user and you want a really good autocompleter, use that. There will be a link down in the description bar down below. Not only is it a really good autocompleter, but it's also like a really good spell checker, and honestly this thing's a lifesaver. But now we'll get back to reality. What we're going to be doing here, we're going to just say print this is the new stuff. All right. And we're going to say tab, and now we're going to run it. And then let's go down to this is the new stuff. All right, so this is from here down is everything that we just created in today's video. All right, where we're just going to let's go to line 96. We're adding a new node. We're going to say data.insert equals price of 200, symbol due, current percentage 54, overall percentage 45, and we're going to insert this into index 2. So let's go over to here. Since this is the very first one that we're going to be adding, let's just double check. 0, 1, do. Yeah, this value was able to get correctly added to index 2, and then why don't we continue on to the next one? So the next thing we want to do actually is delete do. So what will do you? What will you? So do actually was able to successfully get deleted. Now let's go down to line 100 where we're saying print the value of data.contains, and we're going to be passing in the symbol value of you, and it's saying true, we still do have it. Now that's correct. Now if we were to do, let's just say do, and then run it again, it's going to be false because we just deleted this value. Alright Islanders, you all now know how to properly implement a linked list. The reason why we went over how to actually create a linked list, we'll be getting more into on this Sunday's video at 10 a.m. Eastern Standard Time. So if you're not yet subscribed, please do consider becoming part of the Islander community and hitting that bell icon so you can get notified when this Sunday's video gets posted. Like I mentioned in today's video, earlier in today's video, if you have any ideas about what a linked list could be useful for, go ahead and leave it down in the comment section down below. Or if you just have any questions about linked lists, go right ahead and leave it down in the comment section down below as well. If you found today's video really enjoyable as well as beneficial, please do consider hitting that like button. Honestly, all the 3 things that I just mentioned really do help support this channel grow on the YouTube platform. And another way, while we're on that topic, if you know of someone that would find this channel very beneficial, please do not hesitate to share this channel with them. All right. As always, happy coding, and I'll see you all this Sunday. Bye.